Did you know that you have a beautiful brain? That's right, you have a beautiful brain. You may be familiar with the verse in the Bible, it's Psalms 139:14, that says that when we were formed in the womb, God declared us beautifully and wonderfully made. But did you know that every baby is born with about 100 billion neurons? That's about the same number of the stars in the Milky Way galaxy. Did you know that by the end of the baby's 8 month, he can have as many as 1,000 trillion connections in his brain? Did you know that at its peak, the cerebral cortex of a healthy toddler may create 2 million synapses per second? And did you know that the average adult brain weighs only 3 pounds, it's about the size of a cantaloupe, and it uses 20% of all the body's oxygen? At 3 years of age, that baby's brain has reached almost 90% of its adult size. Also, did you know that the right side of the brain controls the left side of the body, and that the left side of the brain controls the right side of the body? Our brains are like the little engine that could. It's always saying, I think I can, I think I can, I think I can. And it does. Even during sleep, it's completely active. Anyone ever have a great dream? You know, our brains are designed from the bottom up and the inside out. To illustrate what I mean, I'd like to use a special prop. In fact, I know that each of you brought this prop with you, and it's called your hand. So if you'd indulge me and raise your hand, now repeat after me. I swear this training is amazing so far. Okay, that really wasn't my point. But I just want to have a little fun. But I do want to describe what is called the Triune Brain. The idea of the brain consists of 3 layers, each built one on top of the other, was proposed by Dr. Paul MacLean in 1985. And more recently, Dr. Daniel Siegel, a leading researcher at the university, researcher and therapist at UCLA, came up with the hand model of the brain. So if you hold up your hand and you look at the palm and the wrist area, this would describe what is called the brain stem and our nervous system. Now, that's a very basic or primitive area of the brain. It controls a lot of our involuntary functions like breathing and heart rate, which are important things for us not to have a lot of conscious control over, right? You want this to be operating even when you're not thinking about it. So that's what this function of the brain does. Now, if you pick your thumb and you put it into the middle of your hand, you have what's known as the limbic system or the emotional brain. This part is directly between your ears, right in the very middle of your brain, and it's sometimes described as the midbrain. And if you take your 4 fingers and place that over the top of your hand, you have the cortex and a very important area in the very front called the prefrontal orbital area of the brain. So this would be kind of a hand model of the brain, kind of a side view, a front view. Now, the middle area of the brain is probably one of the areas that we're going to talk about the most as we look at the effect of trauma on the human nervous system. This area, the midbrain or limbic system of the brain or the emotional brain, is very important in that it controls all of our fight or flight responses. In this area of the brain, there's this thumb that we start up here, this kind of tip of the thumb, which is sort of an almond-shaped organ in the middle of the brain called the amygdala. Now, the amygdala is constantly searching for threats of danger. It's kind of like your smoke detector in your house, because what happens is it's always looking for smoke. Now, in our house, we would often burn the toast. And when we do that, the smoke detector would go off. Now, the smoke detector wasn't smart enough to know that it was just the toast that was burnt and the house wasn't burning down. That was our job as the executive functioning skills, or the more cortex or prefrontal areas of the brain, which we'll talk about in a minute, to oversee that this was not the house burning down. But the amygdala's job, or the smoke detector's job, simply to warn us. Now, it's going to go off each and every time we burn some toast, because every time it detects a threat, i.e. smoke, it's going to make an annoying buzzing sound. Interesting enough, the same area of the brain also has in it a learning center and a memory center. So you have a alarm detection center, a learning center, and a memory center, all housed in the same location. Now, if that doesn't sound like a recipe for post-traumatic stress disorder, I don't know what does. It kind of makes a lot of sense when you think about it that way. So this area of the brain, as I said, its job is to remember things that have been a threat in the past, and whether they're real or perceived in the present, that we are to protect this organism called the body as in whatever way possible. So if we detect smoke, a threat, this area of the brain will literally hijack the rest of the brain in order to function and protect us. So we'll come back to that. Let's go then with this cortex. So if we fold the top part of our forefingers over the top, again, there's a side view and there's a front view. This area of the hand model of the brain is our cortex. The left side and the right side controlling the motor strips for our motor behavior, the back of the area of the brain controlling a lot of our visual centers, doing a lot of complex sort of functions. And the front area of the brain is the area called the prefrontal orbital area of the brain. Sometimes we do call this the executive center of the brain, or the executive subsystem of the brain. Now, it's very important because what it does is it controls things like impulse control, working memory, planning and organizing, moral judgment, and emotional regulation. All things that, as you notice, a lot of children don't have, particularly children who have been traumatized. Now, all children to some degree have very poorly functioning executive skills. It's really the last thing to develop. When a child is born, they come into the world with their brainstem and the nervous system completely intact, which is a good thing again, that is working. So it has a series of primitive reflexes and drives that it already has. It knows how to poop, it knows how to eat, it knows when it's hungry. And when it's hungry, or when it's cold, or when it's wet, it will let you know because this next area of the brain, the emotional area of the brain, will screech. A lot like that smoke detector. I'm uncomfortable, I'm not happy, I'm going to let somebody know. And then somebody comes and takes care of the problem, i.e. then inputting into the cortex and this prefrontal area of the brain, input about what it means to feel safe and trust your caregivers. So the baby comes into the world with an operating system. But this operating system requires software to input and to update the brain system so that it can function in a more complex way, i.e. emotional regulation, i.e. planning and organization, i.e. social skills. That's why when a small child, like a 3-year-old child, drops their ice cream onto the sidewalk and they look down and they just start screaming. If someone they don't know when they're 1 year old looks at them and tries to talk to them, interact with them, they may start screaming. So they may get startled by a dog bark and they start screaming. That's because the emotional center of the brain is the area of the brain that's the most in control of their functions. And they haven't had the software yet to manage their body, their mood, to understand what's happening around them, to have more complex social and emotional skills. They have them, they just don't have them refined yet. As a matter of fact, these skills are not completely developed until our mid to late 20s. So I'm sorry if you're 25, and you should get it any day now, just want to let you know. But we have to input the rest of the information into the hardware. That comes through the interaction with caregivers.